Hello, everyone, and thank you for joining the Knowledge Graph Forum 2023. I hope you enjoyed the first session of the day with our CEO, Atanas Kyriakov, because now it's time for the next one with our CTO, Vasil Momchev, who is here with me, and we'll talk about the product portfolio and roadmap updates of GraphDB and the other Ontotext products. Before we start, quick mention that um, we have a chat box in which you can share your feedback during the session and also ask questions. If there is time at the end, Vasu may answer a few questions. If not, you can expect the answers by other means, either through our booth or through email, or we'll find a way to answer your questions. With that, I will give the floor now to Vasu to begin his presentation. Vasu, the floor is yours.
Thank you, Yasan. Hello, everybody. Dear clients, partners, users. I'm very glad to see you once again after 1 year. And I'm very eager to share all the latest portfolio updates and also give you some highlights on our main products. And of course, on the last part, I'm going to cover what we can do and what you can expect from the future in the future. Okay, without any delay, let's start with the portfolio. And in the beginning, it was the GraphDB in the center of the universe. And why really the people needs this product? For those of you who are new to this product, GraphDB is really optimized database product for handling metadata. And the metadata, as you have heard, it can be semantic. Semantic metadata means that it allows you, it's like it allows you to people to align around the meaning of the information. Meaning in the computer science means that they will agree over the schema, the type of entities, what is their meaning. It's a kind of a data contract. But where this metadata comes from? And the next question is really, yes, it can generally come from unstructured documents or structured databases. So let's try to draw them and continue the Atanas diagram. And in his presentation, he referenced these type of tasks as semantic knowledge hub. This is the task where there is intelligent processing of documents where against the structured metadata, logic will extract some further metadata information and store it in the graph database. And the other case is really of data fabric. Data fabric means that you have multiple silos applications which, for various reasons, do not expose their internal data model. And you want really to extract this type of information, which is important to your business, model it, and expose it to all users in the organization. This use case is also a data fabric. And one of the most common questions we get from our clients and users is, but can you give me some tools how I can process this type of information from unstructured documents and data? And of course, our answer is yes, we have two products. One is the Metadata Studio, which allows you to curate and control the quality of the process, how metadata is extracted from documents. And the other is Ontotext Refine, which allows you from structured data to populate the graph model, including reconciles data, normalize it, and align it in a consistent model. And on top of it, we give you also a tooling for the developers, how you can expose this enterprise knowledge graph with the tool called semantic objects, which expose all this information and can control the access over a GraphQL endpoint. So let's draw them on this diagram. So we have on the left side the Metadata Studio, which allows you to ingest data from unstructured data, and the other is Ontotext Refine. But are these products everything you need in order to handle any use case? What about instance management, some more complex workflows? What about some users who are not familiar with the interfaces of the semantics like RDF, Sparkle? They cannot code this. Can you give me really something which will fit my scenario? And our answer here is very clear. The Ontotext portfolio has a lot of portfolio partners who offer specialized product which can solve these type of tasks. Each of these partners, they invest person years in their products, and they're really the top experts how they can solve various tasks around the management of semantic knowledge hubs or data fabric. And in our Ontotext portfolio, I'm really happy that we work with so many smart people. So I'm going to show a bunch of these guys who have portfolio elements who which nicely integrate with GraphDB, and you can use them in order to build and deliver really the complex enterprise knowledge graphs. What will happen to the clients and users who don't have the technology or the engineering capacity internally to deliver and implement these products? Sometimes even these type of clients, they cannot even convince their business users why they need the enterprise knowledge graph. And our help here is that actually our ecosystem is much bigger than what we have only from portfolio. And there are a lot of solution providers and consultants who can help you model your ontologies and really address this on the business level. So I really want to expand this type of a list with further partners here. So the Knowledge Graph Forum is the best place where you can find everything what you need for delivering enterprise knowledge graphs. And in the next 3 days, you're going to see the recent highlights of all these products, and you can meet these type of companies who are top experts in this domain and can deliver this type of a technology to your business. So I'm really very thankful to all these type of people who participate, and I hope you enjoy the event. With that, I really want to move to the highlights of the Ontotext products. And the first highlight I want to really explain is the talk to your graph. What is talk to your graph? Imagine that you have a domain model. Basically, this is the understanding about your business, which is in the head of every person. We call this ontology. So knowing what is a customer, what is account, all these agreement for the various things. Imagine that on top of this knowledge, you want also to add all records of internal information, like database records, the client list, and everything which is really filling this type of ontology with the instances of the data. On top of it, all organizations, they have their own way how to organize some processes, and there is a lot of knowledge hidden and worked in these type of internal documents. So basically, what we want to do at the end is to fuse this type of information and let non-trained users using natural language interface and queries to talk with this information and to find quickly all this relevant information. So this is basically talk your graph, and let me show this how it works. So we're going to complete this type of exercise, part of the GraphDB documentation. So you can select any RDF dataset. In this particular case, we get some simple example, which I hope will be understandable by all the people here. So this is the Star Wars dataset. And this is an RDF serialization for those of you who are not familiar. But basically, it says that there is a human object. It has a identifier. It says that this is a character and a human. The name of this person is Luke Skywalker. It has really the year when it was born. There is some description and some further metadata, like the height, homeworld, mass, skin color. So basically, this is really the metadata and the entities every business needs to deal. And in this example, we are going to show how you can really build quickly a conversational engine on top of this data and fuse it with all information you need. So the first part is really selecting the metadata. And if you see on the last few lines, there are also links to Wikidata and other external data sets, which can give you really the information, what is known in the public world. So one of these best strengths of RDF model, it uses global identifiers, and various organizations and people can cross-reference this information and really state important information to it. So the next step is really to import all this information and the relevant information in the GraphDB data instance and to have really the first graph. So what's the next step in order to be able to talk with this type of data? For the GraphDB users, probably they're familiar with the so-called connector schemas, but the connector schemas describe how you can select parts of the graph by designing graph patterns, select this type of information, and to declare important objects for this type of application you are building. So in this case, this is the Star Wars connector, and we're going to take this important information from the previous RDF, and we'll say that there is an instance. We want to take what is the type of this instance. So what is the label of this entity, the mass, the height, and all this type of information. So this is a shorter schema diagram explaining how you can select different graph patterns and say, okay, these graph patterns are some important business objects to me, and describing the type of schema. So in this case, we are going to find what is the home world, what is really label of this, and so on. So let's move next. What is really talk to your graph? Talk to your graph is really integrated chat interface in GraphDB, which allows you, once you index all this information, it will be automatically built to talk with your data. So you can ask, who is Luke Skywalker, who is the highest person from some planet, and answer any type of questions using the latest state-of-the-art generative AI technology. But probably few of you will say, okay, I know what is the LLM. We're following all these buzz in the last 1 year around the LLMs and even longer. How is it different if you go to ChatGPT, another type of interface? So our answer here is that the talk to graph really gives you a better and high quality answers. And let's do a side-by-side comparison of the two systems. On the left side, we have the OpenAI ChatGPT 4 versus GraphDB with talk to your graph with Star Wars dataset. Later on, we will explain how this is the difference and why one is giving better results. So let's start with the very first unspecific question. Who is Luke? And ChatGPT, of course, doesn't have this type of context and say, to help you better, could you please provide more context or specific details about Luke? On the other hand, the knowledge graph, which is initialized with the Star Wars datasets, automatically knows that Luke Skywalker is a character from Star Wars. And if you have all these type of metadata, which you have seen earlier on the RDF snippet, and this is the data which is stored in the knowledge graph. So this is really the first big difference, is that you can ground, the term is to ground some of information. But let's continue with more examples on this. The second one is, who is the highest person from Tatooine? Tatooine is really one of the planets of Star Wars film. And if you see highest person from Tatooine, obviously ChatGPT knows, because it's a very specific name, and it knows that this is from Star Wars dataset. It's a functional desert planet. But on the other hand, if you really read later, you see that if you're referring to highest in a different context, please provide more details. So it's really not very sure highest whether it's really the most influential and impactful character, or it's really with the physical highest person. But if you go to GraphDB and ask the same question, you're going to get the immediate answer that the tallest person is the Darth Vader, who stands for 2 meters and 2 centimeters. How this is happened? Because we have this type of information in the graph. If we go further with some examples, I was really trying to make the Sparkle query. Sparkle is the query language of GraphDB, and I wanted to double check that this answer is the correct one. So I made this type of a query, and yes, the database gave me the same answer, which is the Darth Vader has a height of 202 centimeters. Okay, so the next thing is you can do more complex things, like you can ask for the average height of the characters, and obviously you get all this type of functionality. So underneath there is a database query which will go, okay, I know that this is Luke Skywalker and all these type of people, and it's going also to give you really the motivation why the engine believes this is the average height of the people. So the average height of these characters is 163%. So I'll explain how this works and why this is a better way to really approach the general LLM type of technology. So one last question, I was really curious to give some question which is totally out of context. For instance, who is Vasil Momchev? And if we go to ChatGPT, we are going to find out that first, the knowledge base is from January 2022. Actually, I'm a bit older, so it should know something for me. And what we know from the public space is that Vasil Momchev is not a widely recognized public figure in international media, academia, or other prominent fields. Oh, how sweet from ChatGPT that they label me in this way. But if we go to our really grounded knowledge graph, we are going to find a much more precise answer. I'm sorry, but there is no information provided about Vasil Momchev. I can only provide information based on the data inputs. And if Vasil Momchev is related to Star Wars, please provide more information so I can update my knowledge base. Okay, so this is really the main difference and why talk to graph is something needed, which is additional to the public, to the other LLMs and chat interfaces you can find, as often referred as large language models. So the underneath pattern and how this works is that this is the state of art of the general purpose question answering. So the idea is that you get some information from a structured graph knowledge, and you can build a context or grounding windows, how it says, in order to give it to the LLM in order to give a better answers. And it has multiple reasons why the people, and this is the recommended pattern of using LLMs. The first is that typically many of the LLMs, they are trained over large amounts of data, but they lack this type of common subject matter information about the domain models. And you have seen that in this particular case, hate is something very particular, the physical hate of every character. And the lack of domain knowledge cannot be easily ingested. The other thing is that, as you can see, even OpenAI has a massive budget. They're unable to catch up with all the updates, and their knowledge base is back out as January 2022. So it's not easy to do anything incrementally. While if you use a knowledge graph, it's very easy, and you're going to see that it's even transactionally safe. And expensive, obviously, the price, we are not going to discuss this, that you're going to see that using the knowledge graph, you get the fraction of the cost in order to train the same type of interface. And obviously, the black box and the hallucinations is a huge problems of the LLMs you cannot control. So this is the architecture of how we implement this. And I'm sure that you're all technology people who are interested to see how this works underneath. So GraphDB 10.4 or the later versions, you have this talk to your graph interface part of the product. It calls the GraphDB engine, and underneath there is a ChatGPT retrieval connector. The ChatGPT retrieval connector takes the scheme of the information, index for every type of entities, builds a vector. It's using OpenAI API to build this vector and store this in a vector database. And once you get this type of information and domain model, you can conversate using the OpenAI. So the difference is that not all your information is stored on OpenAI, it's stored in a local vector database. And using GraphDB and the knowledge graph, you can very easily build these type of entities and change them on the fly. So you select the part of the graph, you index all this in the vectors, and last but not least, you get the full integration with Sparkle. Let me see how you can also use this. This information is publicly available. It's part of the GraphDB 10.4 release. It will take you not more than 5 minutes to set up and replicate this type of an example. And I'll be very happy if you can contact us and help us improve this functionality. We're very interested to understand how you would use this type of data and get your feedback. So underneath the ChatGPT connector, it's fully integrated in Sparkle. So it allows you this real-time synchronization. As soon as you add new type of characters, they will be automatically indexed, their vectors will be built, and all the other vectors will be re-indexed in the vector database. This is so safe that it will happen in the context of the same transaction. This is a full database. So as soon as you commit something or roll it back, all your data will be fully consistent. And GraphDB supports integration with the total in 12 popular vector databases. You can choose them, and if you want, you can even directly query them using the interface, not going even through GraphDB. And all this functionality, which you have seen, the conversational interface, you can also use this in Sparkle. So in this particular query, who is Luke, the database is going to return the entities. And for these entities, you can further with Sparkle and structured knowledge extract the name and the height and find out the same type of information. This is the height of Luke Skywalker. So it's fully integrated with our Sparkle engine. And for the people who want to really do and generate RDF, we have these OpenAI GPT functions, which allows you on the fly to call something. And for instance, if you have a grape in the wine in your wine ontology, you can ask ChatGPT, okay, what wine from this grape, what type of wine you can use, or what is the brand of wine using for this grape. And this is a seamless integration, everything in the same Sparkle execution engine. So this is pretty much everything. Now I want really to cover that not everything is really functionality. And many of our clients are really using now big cloud contracts. And GraphDB was using always the principle that we are cloud agnostic and the product will work on any type of a platform with Java virtual machine, regardless whether it's really virtual machine, Kubernetes cluster or whatever, we really support one product over multiple type of channels. But with the time, we found that many of our clients really they committed to big contracts with Amazon or Microsoft Azure, so they really want to get this from the marketplace. And now GraphDB is really has a standard SaaS offering on the Amazon marketplace, and later this year it will appear also on the Azure marketplace, where the people can really purchase the software directly with zero interaction with the Ontotext. The principle is that for in the operational mode, the people can choose between two modes. One is the self-service, where they'll do all the administration, installation, and configuration, and Ontotext is going to provide really the technical support and service level agreement in terms of if you have problems with the product, how to really install this. And the other option is really the managed service, where Ontotext is going to manage this type of instance for you. And we are going to give you these service availability metrics, response time, uptime, and so on, in order to really fully outsource all the knowledge graph operation on our own. What is common between these two models is that in the two cases, all our operational scripts and everything is open source. We use Terraform and help charts. And if you really want, it will be the same type of infrastructure and product, but the people who operate it will be different. So this is a big development on our side. So if you really want, you can find us on the Amazon, and either you can take the public or negotiate a private offer with somebody from our subs team. So what we have also next is the integration of data platforms. This is very important because the knowledge graph projects typically does not start on a greenfield, and I'm sure that many of the clients have already quite big data ecosystem. And the question is now how you can integrate with this type of a ecosystem, and what you can how really to bootstrap the development of a knowledge graph. So here are the latest data integrations GraphDB supports, and they're really you see on the right side of your diagram. On the left, we see the data platforms. Under data platforms, we say that they're Databricks, Snowflake, Dremio, whatever is really your approach on enterprise way to manage the data. Or if you have some silos application backed by SQL type of databases, like Postgre, Oracle, MySQL, we support integration with more than 20 popular type of platforms. So it's a very easy to do a simple transformation between the data and to get really data outside of these data platforms and put them in GraphDB. So first, we are going to expose them with the virtual graph repository, which allows really with a simple decorative mapping, R2RML or OBDA, to see the data there and to query them like a virtual repository. In the case if the virtualization is not enough, you can always really replicate the data in a native graph repository and benefit from all the native graph analytical tasks like search between different paths in between different resources, do additional indexes like or upstream and downstream replication. When I say replication, it's very common now in the enterprises that there is a really Kafka service bus which allows you to read and write data. And GraphDB comes with default by standard components like the Kafka sync. This is really a component which can automatically subscribe for changes in Kafka like messages. And these Kafka syncs can also translate these type of messages into RDF calls to the native graph repository. So if you have another database, you can easily build a replication script using the Kafka sync to get the data and update it in your native graph, and to not be needed at all to manage custom data pipelines or any type of ETLs. On the other hand, also GraphDB supports downstream replication with the Kafka Connect, where for every change, including even if there is an inferred data, you can subscribe for all the changes downstream and consume them from other type of applications and synchronize their state. The native graph repository also integrates with Elasticsearch Store and other type of search analytics databases, including now vector databases, which can automatically replicate this type of a state. So with these integrations, we hope that the burden of synchronizing different type of systems, we are going to facilitate it for you and give you all the toolings in order to be easy to synchronize all your information. So this is not everything, and there are other important updates. I'm really going to give just some references there. One is really revolutionizing the knowledge graph-based applications, where Martina and Todor are going to show you that we're not only providing knowledge graph software, but we can also give you the data. And they have really one of the bigger knowledge graphs in this type of space, with all data really aligned and mapped. So get to this type of slide presentation if you're interested how you can get the knowledge graph also populated with data. On the other hand, we have deep dive on Borisław Ankov, how you can transform unstructured documents and populate a knowledge graph. And from the kitchen, Bob Ducharme this is our main technical writer, is going to explain how we really approach the training and how we restructure our documentation and what we can expect there. And also, last but not least, we have an internal project with our marketing. So we are using our technology also to build an Ontotext knowledge graph. This is how our marketing is basically managing all their data and assets in a semantic way. So once we have the roadmap, I'm going to just give you really preview. If you're interested, obviously we can do a focus sessions with our clients and partners to give more details. But really the important things for us is the easy use of the software. We know that some people see that the knowledge graph is really difficult to use technology. Actually, we don't believe this is the case, but we try to everything possible to lower the barrier for any type of developers to start using it. So one of the new features coming in our roadmap is the JSON LD 1.1 support. In other words, this is the feature which will allow to import and export any type of JSON, even if it's not semantic, using the latest standard and to translate it into RDF in an easy way. The name graph security or the quad level security is the next type of a feature which will allows you to do a finer granularity of the access control over the database. So there was a pre-release now, and later, maybe early next year, there will be really the full release where this will be also for the write operations. We have also in our roadmap the application-specific libraries like Python library and for other type of programming languages of how you can use GraphDB. Typically, you can use now the popular RDF popular databases like client application libraries like RDFlib, but we are going to give you a much more optimized client. As you have seen, we are doing a lot on the integration of artificial intelligence, machine learning, large language models. There will be a specific topic there. And last but not least, we are really always committed to increase the scalability of the engine. So we are really going to announce soon something with a significant faster database performance, and especially the performance of the write. Always we are committed to the enterprise software, and we are going to give you all the security and reliability updates, bug fixing, and excellent support if you need it. So this was everything. Thank you, and really I wish you to enjoy the conference. Bye-bye.